Hi everyone, this is lesson 4.3 for Algebra 2A, and this is a just very basic introduction to the unit circle. Now I say introduction, but you guys have done unit circle for the last 2 years, so you're vaguely familiar at least with how the circle works. Today's lesson is really just focusing on the mechanics of the circle. We're not going to be filling in all those exact values, although that's coming. It's just to get you to kind of be able to navigate the circle. So I'm starting you out here with what the textbook gives as a definition for the unit circle, which you probably read and think like, oh my gosh, I have no idea what they're talking about. And I agree with you. This is not a super useful definition to me either, but I'm going to try to explain it to you in terms of the circle. So I think a more simplistic definition of the unit circle is just that it's a circle on the coordinate plane with a radius of 1, okay? So when I draw my unit circle, okay, this is like the origin of an XY axis. And I think sometimes we lose sight of the fact that this is really just a circle on a graph, okay, where this is like 1 in each direction. And so the coordinates of this point would be 1, 0. The coordinates up here would be 0, 1. This is -1, 0, and this is 0, -1. Okay, that's just how the coordinate plane works. We know how the graph operates. Okay, and we always start kind of this is our starting position on the unit circle. Is we always start kind of with this line here, which is why this thing makes reference to the point 1, 0. And so what they're saying is I can take this point 1, 0 and I can rotate it by an angle. And that angle they're using theta to represent. So by magnitude theta, I can rotate this point maybe up here. Okay. And so really this angle is now theta. And what they're saying is that this point would have the coordinates cosine theta, sine theta. And that is going to be important for you to know, that anywhere on the circle, the coordinates can be found by doing the cosine and the sine of whatever angle it's referring to, okay? I'm going to convince you of that real quick. I want to show you why that's true. And I did a much more detailed video on this for Algebra 1 last year, and maybe I'll post that in case you're more curious or just want a firmer foundation. But just real quick here. If I were to complete this triangle here, if I were to draw this triangle out, okay, I would know I have a right triangle here, so I can use SOHCAHTOA. And then the most important piece is that, remember we said the unit circle has a radius of 1. So this length here is a 1. Okay, from here to here, that's a radius. Now, my circle's drawn really badly because that should really be the same size as this, and I didn't do too well drawing this over here. But this should have a length of 1. So if I were to ask you for the cosine of this angle, you would say it's this length over 1. Well, since it's over 1, it's really just whatever this length is, right? That's the cosine. This length is the x coordinate that would show up right here. If you think about on the coordinate plane, this is the x coordinate of a point on the plane. If I were to ask you for the sine of the angle, you would tell me it's this length, which is the opposite side. That's the height, or that's y, over 1. So cosine of theta is x, sine of theta is y. Okay? And if you think about, just get rid of the circle and just think about this dot being somewhere on the coordinate plane, this distance would give you what x is, and this distance would give you what y is, if you just think about it in terms of x and y on a graph. So that's kind of the really important thing to know about the unit circle. We should also probably know that, so since cosine is on the x-axis, cosine is your x values, right? That over on this side, the right half of the graph, the cosines are positive. Over on this half of the graph, the cosines are negative. Okay, so anytime you're going back this way, you're going to have negative cosine values. Here it's going to be positive cosine values. Your sine values work on the y-axis. So anything on the top of the graph, your sine value is going to be positive. Anything on the lower half of the graph, your sine value is going to be negative. Okay? Which means if I'm in this quadrant over here, I would expect my angles to have negative cosine values and positive sine values. If I'm in this quadrant down here, I would expect my angles to have positive cosines and negative sines. Hopefully that makes sense. Okay, one other thing to throw at you. So we've talked about cosine, we've talked about sine, we need to talk about tangent. Well, if you think about tangent of theta here, tangent would be opposite over adjacent, right? So it would be y over x. Well, we know that y is really our sine, and x is really our cosine. So we have this relationship right here, that tangent is really just the sine divided by the cosine, which we're going to get a lot deeper into when we start talking about exact values. But you will want to know this relationship, that tangent is equal to sine over cosine. Okay? And so let's think about what that means as far as tangent being positive, tangent being negative. In this quadrant, so this is quadrant 1, and I guess I should label that because I think sometimes we forget what our quadrant numbers are. This is quadrant 1, the top right, this is where we start. And in this quadrant, our tangents are always going to be positive because it's a positive sine divided by a positive cosine. Okay, so positive tangents. In this quadrant, we're doing a positive sine divided by a negative cosine. And so a positive divided by a negative is going to give us a negative tangent value. So our tangents are negative over here. In this quadrant, we've got a negative cosine, or I'm sorry, a negative sine divided by a negative cosine. A negative divided by a negative gives us back a positive. And in this quadrant, I've got negative sines divided by positive cosines, so that's going to give me a negative tangent value. So what that really gives us is in the first quadrant, everything is positive, right? Sine, cosine, tangent, everything is positive here. In this quadrant, you've got negative cosines and positive sines, which leads to a negative tangent. This quadrant, you've got negative sines, positive cosines, negative cosines, which means your tangents come out positive. And then in this quadrant, you've got positive cosines, negative sines, and so your tangents come out negative. So I don't know that I would try to memorize that. I would focus more on trying to understand it. Why is that true? And if you get this relationship, if you get that x is the cosine and y is the sine, you already know how the positives and negatives work on a graph. So that should make sense to you. I guess the only other thing that we'll throw in on our picture here, because it does refer to this down here, we're not going to get into all the different angles that are on the unit circle, but I guess we should know kind of our four corners, right? So because this is the point where we're starting, this is really 0 degrees. If I were to turn from here to here, that's a 90-degree angle. Halfway around the circle, so this turn right here would be 180 degrees. So this over here is 180. That makes this guy down here, if I go another 90 degrees past 180, this is 270. And then all the way around the circle we would say is 360. And we could do this same thing in radians as well. However, I think we'll save that for when we fill in the entire circle and we're talking about degrees and radians and the relationship between them. But to answer these questions, you're going to want to know at least those points there. Okay, so like for example, when it says evaluate the cosine of 270, I'm going to find 270. I know the coordinates at 270 are 0, -1. And because it's asking for the cosine, I'm going to grab that first coordinate and say cosine of 270 should be 0. The sine of 270, I'm still living at that same point. I'm still living with that same coordinate. The sine is the y value, so I'm going to say that my sine is -1. Okay. Those ones, by the way, would check easily in your calculator. Once we get to some of the more like obscure exact values, you're going to have some crazy decimals that won't work so nice in your calculator, but you should be able to type in cosine 270 and sine 270 and see those two values come out like we thought they would. Okay. I would focus more on understanding where they come from on the circle, but the calculator is a good way to check. Okay, so let's talk about tangent of 0. So here's 0 degrees. Whoops. Here's 0 degrees. I might have to zoom that out for you guys a little bit. Okay. Here's my sine, here's my cosine. So remember, tangent we know is sine over cosine. So looking at 0 degrees, that would be 0 over 1, which is just equal to 0. Okay, so the tangent of 0 is 0. How about the tangent of 270? Well, that's also going to be sine over cosine. So in this case, the sine is negative 1 over the cosine of 0, and that lines up with what we set up here, right? This is a problem, right? We can't divide by 0, so we say that the tangent of 270 is undefined. There's only 2 places on the circle where that undefined thing happens, here and here. Okay, so you get undefined tangents at both of these places because the cosine, which is on the bottom of the fraction, is equal to 0. Okay, everywhere else you should be able to find all 3 trig values, sine, cosine, tangent, but the tangents are undefined at 90 and 270. And again, we could check that in our calculator. We could do tangent of 0 and see that it's 0. We could do tangent of 270 and watch what's going to happen. I get this domain error, which is what happens when I get an undefined value. Okay, keep going. Find to the nearest thousandth the coordinates of the image. And I think I put the definition here, this definition that I gave you back here. I put this in here specifically for this question. It's talking about the image of the point 1, 0 under a rotation of a magnitude theta. That's what your unit circle is all about, is taking this point 1, 0 and rotating it by a given angle measure. So in this question, what they're saying is they're rotating 1, 0 by a measure of negative 2 pi over 9. Essentially, that's just telling you what theta is. Okay, that's telling you that theta is negative 2 pi over 9. And I want the coordinates, right? Well, we know that coordinates are just the cosine and the sine of the angle. So all I need to do is the cosine of negative 2 pi over 9 and the sine of negative 2 pi over 9. Now, you might be stressing out a little bit remembering all of the exact value stuff that we did last year, and we are going to come back to that, okay, where you had to answer a question like this, but you weren't allowed to put like decimals here. You had to actually find it on the circle. This question is not asking for that. Notice it says find to the nearest thousandth. Decimals are a-okay here. So I'm going to use my calculator to do this. This is a place, though, where I'm going to have to worry because I'm going to use my calculator to do the cosine. I'm going to have to make sure my calculator's in radians for this to work. So mode, I'm switching back to radians. And then I'm typing in cosine of negative 2 pi over 9. And then I'm going to do sine of negative 2 pi over 9. And those are my 2 coordinates. So this would be, whoops, sorry, the negative's not first. Cosine comes first. So 0.7, and it's a nearest thousandth. So I'm going to go 0.766, comma, negative 0.643. And that's it. That's my coordinate. So anytime it's asking you for coordinates, I want you to just be thinking cosine and sine of the angle. We will eventually talk about exact values that you can do for some angles, not all, but a good fallback is you can always find your angle just by doing cosine and sine in your calculator. All right, example 4. When I say give the sign of each of the following, this type of sign is referring to like positive or negative. I just want to know, is this positive or negative on the circle? So all of these are referring to negative 1 degree. And I don't think I mentioned this before when we drew our picture, although you've seen this before. But when we're moving around the circle, rotating in a counterclockwise fashion, so going this way, is considered to be a positive rotation. So that's positive degrees. Negative degrees are going in this direction. Okay? So your angles, positive angles are going this way. We're typically going around the circle like this. You saw me do that lots of times. You saw me do that when I drew this picture. You saw me do that when I went 90, 180, 270. We normally go around the circle this way. Negative degrees go down like this. So negative 1 degree is going to be down here. And I mean, it's going to be just barely down here, right? But -1 degree is going to be like this point here. It doesn't matter how far down it is. If it's in this quadrant, we know the cosine, sine, and tangent and what they're going to do. Because the x value here is positive, because it's to the right, my cosine is positive. But because it's down below the x-axis, my sine is negative, right? That would have a negative y value. It would have a very tiny y value, but it would have a negative y value. And the tangent is the sine over the cosine, and so since one's negative and one's positive, the tangent would be negative. So based on where -1 degree is, positive cosine, negative sine, negative tangent. And that's all this question wants to know. So positive cosine, negative sine, negative tangent. Okay, that's all you need to know about the unit circle for today. So after this, you should have a lesson 4.3 to be working on. And then when I see you in class again, we will be diving deeper into the unit circle and putting all of those exact values on there. Okay, that's it for me today. I hope you guys have a great day, and I will see you next time in class.